So we had started talking about comparing the first ionization energy, which is just moving the first electron from the outside of the atom, and down the group we did that, and the first ionization energy we figured out that it decreases down the group. So why does it decrease? Because the distance and the shielding effect, they both increase. So it becomes easier to remove electrons despite the fact that the nuclear charge is increasing. So despite the fact that nuclear charge increases, so ionization energy decreases down the group. Now, that's all what you have to write in your exam. One thing that I've noticed recently in the recent marking schemes is that they give 1 mark for a very specific sentence that has to be added, and that is that, and that's a very obvious sentence, which is that before you give all the reasonings, you have to write that the ionization energy is decreasing. Why? Because just a second, let me move this. So you have to add this very specific sentence that ionization energy decreases down the group as nuclear attraction for the electron decreases, or the attraction between the nucleus and the outer electron decreases. So between nucleus, now every time when you write this, add this statement whenever you're talking about ionization energy and it decreases, always mention that the attraction between the nucleus and the electron decreases. And why does it decrease? Because the distance and the shielding effect increases, and so despite the fact that nuclear charge increases. So they always give 1 mark for this very specific statement in the recent marking schemes. So we're going to move towards across the period now. What happens to ionization energies across the period? And it's a comparison of first ionization energies across the period. Now, when you move across the period, and let's pick any period, let's pick period 2 elements. So let's pick period 2 elements. Let's say we have period 2 elements only have 2 shells. So let me draw all of them very quickly. So that's lithium and beryllium, boron. You'll have after boron, you'll have carbon, then you'll have nitrogen, oxygen, fluorine, and the last one would be neon. And this is how the size of the atoms, they all have 2 shells. So when you move to the right, the size of the atom, it gradually decreases. So as you continuously move towards, so let me just quickly. So that's the last one. So this is atoms across the period. One thing that happens when you move across the period is that the number of protons, they continuously increase. So you have lithium, the first one, then you have boron, which is 4 protons. And it's got 4 electrons as well. Then you have 5 protons. That is boron, and 5 electrons. And then you have 6 protons and 6 electrons. And you have 7 protons and 7 electrons, 8 protons, that's oxygen. And it's going to have 2 and 6 electrons. And this one would be 9 protons, that's fluorine. And the last one is going to be your
neon, sir.
Okay, that's neon. So that is 10 protons, and it's going to have a total of 10 electrons. Okay, so this is how the atoms would look across a period. This is how their sizes, they would have the same number of shells. So I'm going to write the factor what's going on when you move across a period. So when you move across a period, tell me, would it be difficult to remove electrons or easy to remove electrons when you move across the period?
Sir, it would be difficult.
Okay, so the ionization energies would increase across the period. The first, just removing the first electron. So the first ionization energy would increase across the period. And what are the factors that are involved? Why does it increase across the period?
The proton number increases, the nuclear charge increases.
Okay, so you have more protons, more nuclear charge. What other factors?
So it has a small radius now. The radius decreases, atomic radius.
Okay, so the atomic radius or the distance of the electron gradually decreases.
Yes, sir.
Or distance decreases slightly as you move towards the right when you move across the period. Now, this is also important to remember this, that when you move to the right, the atomic radiuses, they decrease in the same period, even though they have the same number of shells, but this one has 3 protons, so it doesn't really attract its electrons very strongly. This one over here has 9 protons, so the attraction for electrons is very, very strong. Okay, is this clear?
Yes.
So always remember across the period, I mean, we can draw a separate diagram because you get questions. So you must always know that when you move across the period, atomic radius would always decrease. So if you go from group 1, then group 2, group 3, 4, 5, 6, 7, and group 18. So the atomic radius would always decrease, and your graph is going to look like this. And it's always going to be a gradual decrease, not an abrupt decrease. It's just as you keep on moving to the right, the atoms would always decrease. Now, what other factors? Which shielding is constant, so you have constant shielding, same number of shells. So mention that factor as well, although that's constant, but so that is not a contributing factor. So ionization energy increases, it becomes harder to remove electrons. Why? Because you have more nuclear charge, and you've got the distance slightly decreases. So the electron is closer to the atom, so it becomes more difficult to remove electrons. So if I were to sketch the graph of ionization energies, and remember, this is the general trend. So that is the general trend that happens. Those are the reasons for that. TK, is that clear, everyone?
Yes.
Now, to be more specific, it's not going to be just constant increase. In reality, what the graph would look like is it's going to look something like this. Let's say this is group 1, 2, 3, 13, 14, 15, 16, 17, and 18. So in reality, the graph would look like this. It's going to increase, and then there's going to be a dip at group 3. Then it will continue to increase. This is group 4, then 5, and then there's going to be another dip at group 6. And then there's going to be group 7, and then another increase till group 8. So that's how so it's not going to be a constant increase, although the general trend is the same, but they're going to be dips at group 3 and so 14. I mean, this is 13, 15. So 16, 17, and 18. I saw this one. So what's going on over here? What's going on at group 13, and why is group 16 not following the trend? Although we've already explained that the trend is increasing, but yes, Hamza.
And there's certain elements where the ionization, like their factors, cause them to have lower ionization energies than the element in the group ahead of them.
So why is there the first one? And this is a very popular question. They ask you a lot. Why is there a dip? Or I mean, they're going to state why is group 13 13's ionization energy. In this case, in this case the element is boron. Why is boron having a lower ionization energy compared to the group 2 before that?
So is it because of the electronic arrangement?
Okay, so only over here do subshells they play a role. So what specifically happens at group 13? Like you had group 12. No, it's not group 2. And beryllium was 4 electrons. So that is 1s2n and 2s2. So it had only 2 electrons in the outer shell. And then you had group 13 or group 3. And that was boron. It had 5 electrons. 5 electrons is going to be 1s2, 2s2, and 2p1. So what is the exact reason? Why is it easier to remove electrons from boron?
So because the p subshell is like alone, and it's easier to remove that electrons.
Okay, what you're going to write is that, I mean, think of this as the nucleus. So the 2s electrons are much closer to the nucleus, whereas the
Yes, sir.
2p is slightly further away relative to the 2s. So since this is slightly further away, and it's also more shielded as well, because previously you just had 2 subshells. So there's a change that's happening at group 13. Like between group 1 and group 2, there was no change. This was group 1 is S1, group 2 is S2. At group 13, you start removing electrons from P1. So all of a sudden, you're removing an electron from an orbital or a subshell that is much further away. So your explanation would include that it's easier to remove electrons. So easier to remove electron from boron, as electron is removed from a higher energy, p subshell. So it's removed from a higher energy p subshell, which is more shielded and further away compared to the 2s subshell. So it becomes a lot easier to remove electrons. And this is specifically that you have to remember this at group 13, and this would be followed in every period. Because all group 13 and group 2 electronic arrangements would be very similar. Like if this was magnesium and this was aluminium, then it would be 3s2 and this would be 3s2 3p1, but the arrangement would still be the same and the factors would exactly be the same. Yes, any questions?
Sir, are we specifically talking about the first ionization energies of these elements, or it's the same for all the
First,
ionization?
just the first one.
Okay, sir.
Because if you're talking about the second or the third, then you're talking about different subshells. You're removing electrons from someplace else. TK. Yes.
So why does group 14 go back up?
So now, firstly, the trend is the same, right? I mean, they're all following this trend.
Yeah. There's a general
now over here, the subshells don't matter because it's the same subshell, right? You're removing electrons from the S. You're still removing the electron from the S, right? So between group 1 and 2, that's not an issue, right? The issue only comes when you go from group 2 to, you make this transition from group 2 to group 13. All of a sudden, you're removing from a subshell that's much further away. Now, if you compare group 13 with group 14, the subshell factor is not going to count because it's going to be the same subshell. Is that clear?
Yes.
And even after that, the subshell factor is not going to be an issue because you're still removing electron from the p subshell. So the subshell factor would not really count because it's the same everywhere. But then at group 16, something happens again. Something happens to the subshell and it kind of becomes easier to remove electrons. What happens at group 16? But why is there a dip at group 6?
Sir, because the electrons repel each other. For example, oxygen, in the last subshell, it has four electrons. So the last subshell, it has 4 electrons. So one of them repels each other, and it's easy to lose that electron.
Okay, so you have we have nitrogen, which is that's exactly what happens. You have nitrogen, which is 7 electrons. So the electronic configuration would be 1s2, 2s2, and if I write down all the orbitals, it's 2p3. So that means 2px is 1, 2py is 1, and 2p z is also 1. So every orbital has 1 electron each. But when you move towards oxygen, which is group 16 with 8 electrons, so the electronic configuration now is 1s2, 2s2, and 2p4. Now, when you have 2p4, that means one of the 2p orbitals is going to be, so that's going to be full. And when it's full, the 2 electrons are going to kind of repel each other. And there's going to be mutual repulsion. So it becomes easier to remove electrons because the 2 electrons are kind of trying to knock each other out. Is that clear?
Yes, sir.
So the wording that you're going to use is that, and remember, it's always mentioned, it's always going to be a relative comparison. So when you're answering this, you're going to state that at group 16, whatever the group 16 element is, the electron is removed from a paired p subshell. From a paired p subshell. And because of that, so due to spin pair repulsion, so this mutual repulsion is known as spin pair repulsion. The 2 electrons are due to spin pair repulsion. It is easier to remove electrons. While the other one in group 15, the group 15 element, electrons are removed from a half filled p subshell. electrons are removed from a half-filled p subshell and there is no spin pair repulsion. So there is no spin pair. Spin pair repulsion. So remember, make sure you write this word that you just have to mention that there's a paired p subshell over here, and there's spin pair repulsion. I mean, in this one group in oxygen over here in group 16. So it's easier to remove electrons over there. Over there, there is the p subshell is half filled, so there is no spin pair repulsion in that case. And after that, it's not going to be a factor. It's only going to be a factor when you move towards group 16. After that, all the p's would be paired. So the spin pair repulsion would be constant in all of them, group 17 or group 18. So that's not going to be a factor. So they're going to continue to follow the trend. There's only going to be a dip at when the subshells change, S2, and you all of a sudden start removing electrons from the P, and there's going to be a change that happens over here. All of a sudden, the P becomes paired and it becomes easier to remove electrons. So there's going to be a slight dip at group 16. TK, is this clear?
Yes.
TK, everyone, is this clear? Rima, is this clear?
Yes.
So now another thing that needs to be talked about is a lot of times when you're moving across the period, you're basically you have consecutive proton numbers. So this is proton number 3. I mean, this was lithium. This is 4. This is 5, 6, 7, 8, 9, and 10. Now, what happens right after that when you move across the period? And let's say you're following consecutive proton numbers. After group 18, the period changes, and then you start doing the same thing for the next period. So you start at group 1 again, then that's group 1, 2, 3, 4, 5, and you'll have 6 and 7 and 8. So everything kind of gets repeated after that. So it's going to be the exact same trend for the next period. So a lot of questions are going to be about consecutive proton numbers, which is basically you traveling across the period. So the trend is going to be exactly the same, except that it's going to be lower. So it's just going to be slightly lower, and this is what I'm talking about. I mean, if I so the first period, that's according to consecutive proton numbers, that's 3, 4, 5, 6, 7, 8, 9, and 10. So that's one trend. And then all of a sudden after neon, if you continue to write the elements according to the proton numbers, you start with the next period. And when you start with the next period, the trend would be exactly the same. The orbital arrangements, etc., the subshells would be exactly the same, except the shell number would change. So why is the next period lower than the first one? What's the reason for that? Yes, Amza.
Because you're going down the group, so.
Okay, so the first period is going to have higher ionization energies because the size of the atoms are going to be smaller and they're going to be less shielded. In the next period, you're going down the group now. You're now one level down. So the number of shells increase, and this is what happens. Like we did discuss what happens down the group. When you move down the group, the size of the atom increases and becomes easier to remove electrons. So in the next period, you'll have one extra shell, which is why the trend would be exactly the same, but it's just going to be lower. Is that clear?
Yes.
Yep.
Yes.
Okay, so remember, don't get confused. A lot of times they'll give you just partial structures, like it's going to be the same graph, but they're going to just show you this thing. So make sure you know that when this big dip is coming in, that indicates that the period is changing and you're starting with the next period. So this indicates, the peak indicates, the top indicates that's group 18, and the extreme bottom indicates that's group 1. So whenever you see this thing, so they're not going to draw the whole thing, they're just going to draw a partial structure. So they might draw this partial structure, they might draw this partial structure. So just don't get confused. Make sure you have these markers. The extreme peak indicates group 18, and then that's the next one. So when you see this, this is group 18, and then it's the next one. So they'll always give you these partial structures, and in the fourth period you'll also have transition metals. So if I can show you what happens at period number 4. So this is how the graphs would kind of look like if you continue to sketch them according to the proton numbers. So they're all following the same trend, except, I mean, it's a rise, then a dip at group 3, 4, 5, rise, dip at group 6, 7, 8. So they're all following the same trend. All periods are following the same trend. Just make sure that that in the fourth period you'll also have transition metals. So don't get confused. There would be 10 extra elements that would be there. You don't have to know the reasons right now for these, but just don't get confused. It's the same trend according to the group numbers: dip, rise, then there's another dip, and then rise and rise. And there would be 10 elements in period number 4. Now we're going to start, we're done with the ionization energies, we're done with the across the period, down the group, and successive ionization energies. We're done with all of them. So we'll just start with the past paper questions. Remember, the past paper questions for this, although it's kind of simple, there's just 3 things that you have to remember. So let's start with, where's the so this one. Now remember, the question interpretations, the comprehension of the question is going to be slightly tricky. So this one, the question is, which element has the second smallest atomic radius? What does that mean? Like, how do I figure out the element? What information do I get from this? The second smallest atomic radius.
The one which has the second least proton number, sir.
The
second most proton number.
The second smallest atomic radius. Where would I find this element? Second smallest atomic radius.
In period 2.
Okay, it's in its group. Let me just read the whole statement. It stated that it's the second smallest atomic radius. Ali, it's in its group. So the smallest is going to be this one. The smallest, like if I pick any group, like if I pick group 2 over here, so the smallest would be beryllium. The second smallest would be magnesium.
Yes, sir.
If I pick group 1, the smallest would be lithium. The second smallest would be sodium. So basically, he's talking about period 3. Okay, he's talking.
I didn't see period. I said group.
What's that?
Yes, sir. I wasn't
Group
the one with period.
Okay.
Yes, sir.
So basically, you're looking for these elements over here. So it's got to be some element from period number 3. The second one is that it's supposed to have the third lowest first ionization energy in its period. Now, I know from this, I get the information that it's got to be in period 3, right? And then he's saying it's supposed to have the third lowest first ionization energy in its period. Now move towards period. Which group is he talking about? Like we just did this. So in its period, let's talk about this period over here. The third lowest, which one is the third lowest? Group 1, 2, 3, 4. Which one is the third lowest in the period?
3,
Which one?
13.
Remember, he's talking about the third lowest. Which one is the lowest? Tell me which one is the lowest in the period.
Group
That's group 1, right? Which one is the second lowest?
So group 2.
No, group 2 is higher than group 13, right? So this one, okay, so remember the trick is that this one is the lowest, and this one is the second lowest. So which one is the third lowest?
Group 16.
No,
Group
2.
Group 2. Okay, think of this vertically. I mean, think of the graph vertically. This one is the lowest. This is obviously the lowest, right? And then this one is the second lowest, right? There's nothing. And this one is the third lowest. In terms of its value, this is the third lowest. But think of this as in the vertical direction. Like this is the lowest. I mean, this one is the lowest, second lowest, and this is the third lowest. So it's talking about group 2. Is this clear? This thing? Yes or no? Is this clear?
Yes, sir.
So he's talking about group 2. So basically, the element belongs to period 3, and it belongs to group 2. And all you have to do now is you just have to find the element. So it's period 3 and group 2. So this is period 3, and this is group 2. So it's going to be magnesium. The answer to this question would be C. Is this clear?
Yes.
Yes.
Okay. So just remember, it's more about comprehending the question. I mean, if you misinterpret the question, you'll get everything wrong. Now this next question, it's much harder than that. I mean, the comprehension is a lot harder. So the question states, and this one is comprehension wise, it's a very tricky question. So the question states that element X has a higher first ionization energy than element Y. So the first statement is, let's try and test the first statement. X is supposed to be having a higher ionization energy compared to Y. So is that true for carbon and boron? So let's compare that for carbon and boron. Carbon is over here and boron is over here. Who's going to have a higher ionization energy, carbon or boron?
Carbon.
Okay, across the period, ionization energies, they increase. They're going to be dips at 3 and dips at 6, but not at 4. So even if I go back to this thing, like boron over here is, which one is boron? Boron, I think, is this one, and carbon is group 14. So carbon is this one. So carbon has a higher ionization energy. So that is true. So that means the first option can be true. So I'm just focusing on the first one. What about the next one? Magnesium and aluminium. Is magnesium going to have a higher ionization energy compared to aluminium? So again, if we...
No.
Magnesium...
Yes.
Okay, that is true. Magnesium is going to have a higher ionization energy compared to aluminium. Because at aluminium, at group 3, there's going to be a dip when you move across the period. Okay, is this clear? Ali, is this clear? So magnesium, so it's going to rise, and then there's going to be a dip at aluminium. So that is also true. What about the third one? Oxygen having more energy compared to nitrogen. So oxygen is over here.
Yes.
Nitrogen is over here. Is oxygen going to have higher ionization energy?
No.
No, sir, because there's a dip.
There's going to be a dip. Nitrogen will have a higher ionization energy, and at oxygen, there's going to be a dip. At group 16, you're going to have a dip. So that means oxygen will not have a higher ionization energy compared to nitrogen. And let me just double check. X is supposed to have a higher ionization energy compared to Y. So oxygen won't. At oxygen, there's going to be a dip. It's going to have a lesser. And is oxygen going to have a higher ionization energy compared to sulfur? So here's oxygen and here's sulfur. So is oxygen going to have a higher ionization energy compared to sulfur?
No,
What happens down the group?
it does.
Down the group, the ionization energy decreases. It becomes easier to remove electrons when you move down the group because the size of the atom increases. The electron becomes further away. So oxygen, it would be more difficult to remove electrons. It's going to have higher ionization energy compared to this sulfur over here. Is this clear?
Yes.
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 Okay, so I mean, we just checked the first statement, and that we eliminated C. C can't be correct. Now the next statement is, two students state what they believe is one factor that helps to explain this. So I mean this thing over here, X having a higher ionization energy compared to Y. Student 1 and student 2 are giving their explanations for that. So student 1 states that X has a higher ionization energy compared to Y because an atom of X has more protons in its nucleus than an atom of Y, starting with carbon and boron. Is that the reason? Why is carbon having a higher ionization energy compared to boron? What's the reason for that? Is it more protons?
Yes, sir.
Okay, when you move across the period, the number of protons, they continuously increase. So that is the reason.
Yes,
That is the reason. That is true. So that means student 1, his reasoning is correct. Carbon has more protons. What about magnesium being greater than aluminium? Is that the reason more protons, magnesium having a higher ionization energy compared to aluminium? Is it due to protons?
No.
yes,
The protons is not a factor because magnesium actually has fewer protons. Is that clear?
Yes.
Because the dip happens, it goes against this general trend. The dip happens because of the subshells, not because of the protons. Group 2 will have lesser protons compared to aluminium. Aluminium is going to have more protons. So remember this, that magnesium having a higher ionization energy is not because of protons. It actually has fewer protons. Is this clear?
yes, sir.
So that means student 1 over here, his reasoning is incorrect. What about the last one? Oxygen having more ionization energy compared to sulfur. So why did oxygen have more ionization energy compared to sulfur? Was it because of more protons?
Yes.
No, sulfur has more protons.
Oh, sorry. No.
So it's, I mean, oxygen just has 8 protons. Sulfur has even more protons. So that's not the reason. It's basically the distance and the shielding. That the shielding is less and the electron is closer to the nucleus. So oxygen has actually fewer protons. So student number 1 is also incorrect over here. So student 1 stated that X had more protons. That was true for carbon, but not for the other ones, not for magnesium, not for oxygen, not for these two, not for these two. Is this clear, this thing?
Yes, sir.
Yes.
Yes.
So then let's talk about, so that we're done with student 1. Let's talk about student 2. Student 2 comes up with his own reasoning. He states that X, the reason X has a higher ionization energy is because X has a smaller atomic radius than Y. So is that true for the first one? Why do ionization energies increase across the period? One of the factors was carbon having more protons, right? What was the other factor across the period?
Sir, the atomic radius.
The atomic radius was smaller, right? When you move across the period. I mean, this was one of the factors. You had 2 factors. When you move across the period, like this is carbon and this is boron. So one of the factors is that carbon has more protons. The other one is that the distance is also slightly smaller. So that means student 2 is also correct over here, that X also has a smaller atomic radius. Is that clear?
Yes, sir.
Yes.
Yes.
I said, then is student 2 correct about magnesium Why is magnesium having a higher ionization energy compared to aluminium? Is that because of protons
No,
or
sir.
sorry, the radius? Radius is not going to be a factor because aluminium actually has the smaller radius when you move across the
Hmm.
period. So it's because of the subshells, not because of the protons or because of the atomic radius. So that factor is not going to be true for this one. For magnesium, for the dip, both students were wrong. I mean, both students were wrong because it's not because of magnesium having more protons, and it's not because magnesium is smaller as well. It's because of the change in subshells. Aluminium is the one that's actually having more protons, and aluminium is the one that's smaller as well. When you move across a period, the size of the atom decreases. So both students are wrong over here. What about the third one? Option D. Why does oxygen have a higher ionization energy compared to sulfur? Is it because oxygen is smaller compared to sulfur?
Sir, yes, oxygen has 16 and sulfur 32, so it's smaller.
It's smaller. It has 8 electrons. This one has 16 electrons. It's got one more shell. So that is one of the factors that the reason oxygen it's more difficult to remove electrons is that oxygen is smaller in size, it's less shielded, and the electron is a lot closer to the nucleus. So student 2 is correct over here. That the smaller atomic radius of oxygen is one of the factors. That's why the ionization energy of oxygen is greater compared to sulfur. So is this clear, this thing? Which student is correct and which?
Yes.
So we did the analysis of all three statements. Now this final answer is looking for is that he states that only one of the students is correct. So which is the correct option?
D.
So it's going to be D. Because in option A, both students and the reasonings were correct. In option B, both students and the reasonings were incorrect. And he wanted the answer in which only one of the students was correct. So for oxygen, the greater proton number factor was not correct because sulfur had greater protons. The smaller atomic radius factor was correct because oxygen had a smaller atomic radius. So only one of the students was correct. So option D is the correct option. Is this clear?
Yes.
So don't worry. I mean, you don't usually get I mean, questions this complicated don't usually appear in your exams, but you might get questions where there would be a lot more comprehension. So you have to prepare for that as well. Most of the questions are going to be kind of straightforward. So, I mean, ignore these for now. He's saying which terms can be illustrated by an equation that includes the formation of a positive ion. So in which one is there a formation of positive ion? So is first ionization energy equation correct? Does it lead to the formation of a positive ion?
Yes.
Okay, so first ionization energy is you trying to remove. It does. So
One electron.
you're removing one electron, so it forms Na+1, and it would lose one electron. So that is correct. The other ones are not related to this. So remember,
Sir,
yes.
no, it's 4:30. I have to go to another tuition. Would you mind if we end it, or could I leave?
Okay. I was about to end it. I was just let's start from here tomorrow then. Okay.
Okay, sir. Assalamu alaikum.
Okay, sir. Assalamu alaikum.
Hafiz.
Sir, I have a
Haj.
question, sir.
Yes.
The question we did, the previous question, sir. If we get such a long question in the paper, should we avoid it and start working on the next question, or we should like do it at the moment?
No, it was the strategy is कितने गए?
Like, sir,
नहीं,
normally
मतलब
teachers say that the
नहीं, strategy तो ये कि
question you know and skip the question you don't know. But like in this case, we know the question.
हाँ नहीं, strategy ये कि इस तरह के questions जितने भी है ना, leave it till the end. ठीक है? अब लेकिन you're lucky कि you have 15 more minutes. From now on you'll have 15 more minutes. ठीक है? तो time इतना बड़ा factor नहीं है, लेकिन as soon as you see a very complicated question, just leave it till the end. क्योंकि जैसा कि ये क्वेश्चन है, these are more straightforward. You can probably solve it in 50
Okay.
seconds. ठीक है? Yeah, 30 seconds. You just read the question.
Understood.
So
Sir,
it's
can you share a worksheet of this like the sir?
क्या चीज?
सर मैं कहता कि अगर आप कोई वर्कशीट शेयर कर दें इस टॉपिक
हाँ
की
नहीं
सर, तो वो मैं करके आपसे प्रॉब्लम्स आप डिस्कस कर लूँ।
नहीं, वो तो मैं अभी शेयर करने लगा हूँ, ठीक है? और मैं वो उसकी असाइनमेंट भी दे रहा हूँ, ठीक है?
थैंक यू सो मच सर।
चलो,
थैंक यू सो मच सर।
ओके ओके, अल्लाह हाफिज।